What we have been discussing is the exact landing procedure of our spaceship, which is called ROMIT, which is this alarm clock that I'm going to see if I can demonstrate a little bit of the actual plans. If you think that the Earth is down here, then ROMIT is going to move in elliptical trajectories. It is not going around the moon because the moon is moving like this in a big circle around the Earth. And originally the ellipses are going to be quite small. Little by little they'll be larger because we use an iron thruster, and the iron thruster is giving a little bit of thrust for each turn. So we expect to do something like 200 laps. By 200 laps we will be out where the major axis of the ellipse is going to be as long as the distance to the moon. So at some stage we're going to have to interact with the moon itself. Now we don't want to do this at the wrong time, so therefore it is important that the last 3 laps are made in such a way that we don't interfere with the moon at the wrong time. We want to do it at exactly the right lap. And once we get to that lap, that we want to head a little ahead of the moon, a little further out of the moon, so that the gravity of the moon can take over from the Earth and put this into an elliptical trajectory around the moon. And this elliptical trajectory is designed in such a way that it's going to cut the moon's surface at a certain place. Of course it should be at a place that is in the sunlight, and it should also be at a place where we can connect to it. And that is in principle our landing procedure. In the next part of it I'll tell about how we land without getting crushed.